For this topic, we are going to look at an introduction to decimal numbers. We can look at doing some rounding, some division and some multiplication with and without a calculator. So let's get started. Okay, so when we're looking at rounding numbers, we'll first look at rounding a number to one decimal place. In order to round a number to one decimal place, we actually look at the second decimal place. So in this first one, 5.666, if I look at my second decimal place, I have 6. And the rule is, if that number is 5 or more, we round that number up, which means that we will round that first decimal place up to a 7. It can get a little trickier. If we look at 2.99, look at the second decimal place, and we've got 9. Now once again, we would then look to round our first decimal place up by 1. Well, the problem we have is that if we do that, the 9 becomes a 10, and we can't have a 10. So that 10 forces this 2 to become a 3. So then that rounds to 3.0. The same rule applies when rounding numbers to 2 decimal places, 3 decimal places, or even more. You always look at the next decimal place to see whether the number will round up or if it will stay the same. So this one we are being asked to round 43.6405 to 2 decimal places. So we look at our third decimal place. Now a 0, that is not 5 or more. So the effect that has on our rounding is that we simply are left with 43.64. For this next one, we're asked to round to 3 decimal places. So counting along, we look at the fourth decimal place, and that is 8. 8 is 5 or more. Therefore, the 8 is going to round the third decimal place digit up to a 1. And you will get 0.131. Our next example involves a calculator question that requires us to try and work out a calculation from what the question is asking. So we've been told Jasmine pays £52.40 for 40 litres of petrol. What is the cost per litre? Well, currently we have £52.40 for 40 litres. To get 1 litre, if I was to divide the £52.40 by 40, that will then tell me the cost of 1 litre. This question allows us to use a calculator. So we type in 52.40. We divide that by 40 and we get our answer. Now on this calculator, to change that to a decimal, we press Format, press the down arrow and press OK for decimal, and you can see we have 1.31. So our answer for this question is £1.31 per litre. For these next two examples, we're being asked to multiply an integer, which is a whole number, by a decimal. Now there is a trick to this. If you were just to do the multiplication with the digits that you have in the question, and then we can consider a decimal afterwards. So the calculation I am going to do is 50 multiplied by 3. Which is 150. Now to ascertain as to whether we have a decimal place in this question, we look back at our original question and see how many digits are after the decimal place within the whole question. And in this one, I have 1 there and then no more after that. What that tells me is that my answer should also have 1 digit after the decimal place. So I can place that in here. So my answer actually becomes 15.0, which you can write as 15. We're going to apply the same strategy to 0.7 times 40. Again, we start off with the calculation of 40 times 7. 40 times 7 is 280. And again, we look back in our original question, we count up the amount of digits that are after the decimal place. I've got 1 there, and then no more after that. Therefore, my answer should also have just 1 digit after the decimal place. So I get 28.0. As you can see with the next two examples, it's a little different. We actually have a decimal multiplied by another decimal. The strategy remains the same. We do our calculation of 3 times 7, which is 21. And then we go back to our original question of 0.3 times 0.7, and we count the total amount of digits after the decimal place. I have 1 there, and I have 2 there. That means I should have 2 digits after the decimal place in my answer. So I can place it there. But currently that answer is looking a bit strange. So therefore, we have to add in the 0 that would be before that decimal point, leaving us with an answer of 0.21. Apply the same idea for this one. 6 times 4 is 24. Count the digits after the decimal place. In the whole question, I've got 1 there, and then I've got 2 there. So therefore my answer should have 2 after the decimal place there. And like before, that's looking a bit strange, so we need to add that leading 0. Our multiplication can get a little more difficult. So this will mean that we need to resort to a slightly different method, because I don't know my 74 times table. So I'm going to apply a bit of short multiplication. And I have 4 times 6, which is 24. 7 times 6, which is 42. Add that 2, we have 444. And again, the strategy still remains. We count up how many decimal places we have in the whole question. So I've got 1 digit after the decimal place there. So therefore my answer should also have 1 digit after the decimal place. Notice in my working, I did not include a decimal place at all, because I didn't want to add any confusion. The same strategy applies for this one, although the numbers are a little trickier, so we are going to do some long multiplication. So for 54.1 times 2.6, I'm going to do the calculation of 541 multiplied by 26. So I've got 1 times 6, which is 6, 4 times 6, which is 24, and 5 times 6, which is 30. Add the 2, we have 3, 2, 4, 6. And then we do the same to get the next row. Got 1 times 2 is 2, 4 times 2 is 8, and 5 times 2 is 10. Take care to line up your columns. We add those together, we have 6, 6, 10. Carry that 1, so we've got 3 plus 1, that's 4. And so we get 14066. So our answer contains the digits 14066. We look back at our original question. We count up. I've got 1 there, I've got 2 there. Therefore, my answer should also have 2 numbers after the decimal point. Therefore, my answer should have 2 numbers after the decimal point. For my next example, which is similar to an exam-style question, we have a website selling basic calculators for £4.20 and scientific calculators for £12.50. Mrs. Mostyn buys 5 basic calculators and 10 scientific calculators. She pays with some £20 notes Mrs. Mostyn thinks she will get more than £5 in change. Is Mrs. Mostyn correct? You must show how to get your answer. So in other words, we can't just say yes or no. We do actually have to back it up with some maths. So let's start off by writing down what she has bought. She has bought 5 of the basic calculators, which cost £4.20. And she bought 10 times £12.50 for the scientific calculators. So let's do those calculations. A quick way to do this, if you're times it by 5, you can times it by 10, so you get 42, and then divide it by 2. That is the same as multiplying by 5. So we get £21 there. And then, of course, timesing by 10 for this one. Just need to move our place value. And we get £125. So let's work out how much she spent in total. She has spent 125, add 21, and that gives me £146. And that's the total spent. Okay. Now we need to see how we're going to answer this question, because it says Mrs. Mostyn thinks she will get more than £5 in change. That's after paying with £20 notes. So if we think of our multiples of 20, it's simply the 2 times table multiplied by 10. So I'd have 20, 40, 60, 80, 100, 120, 140, 160. And we can stop there. So Mrs. Mostyn, she spent £146. It's clear that she didn't use £140 worth of £20 notes, because that wouldn't have been enough. She must have spent £160 in £20 notes in order to get the change. So we can now write Mrs. Mostyn used £160 in £20 notes. We can now say Mrs. Mostyn's change so if she spent £160 using £20 notes, and the calculators cost her £146, if I subtract that, I end up with £14 change. This is more than £5. Mrs. Mostyn is correct. And for our final set of examples, we're going to look at dividing by decimals. Now, in fact, you don't need to divide by decimals at all. You can manipulate the question to your advantage. If you multiply both numbers in the question by a power of 10, so by 10, 100, 1,000, or whatever, once you have a whole number to divide by, you can divide what you see and get the same answer. So for this one, I've got 21.9 divided by 0.6. I don't know my 0.6 times table. So I'm going to multiply both sides by 10. So this number would become 219. And this number becomes 6. So I can actually do the calculation of 219 divided by 6. 6 into 2 obviously is 0. 6 into 21 is 3. Remainder 3. 6 into 39 is 6. And I still have a remainder of 3. So we're going to the decimal, and then 6 into 30 is 5. Therefore, my answer is 36.5. No further working is necessary. We can try that again with this one. I've got 238 divided by 1.4. Again, multiply both numbers by a power of 10. That means I'm dividing by a whole number. Well, I can just times both sides by 10. So I have 2,380 divided by 14. Into 2, there is no, that's 0, remainder 2. 23 divided by 14 is 1, remainder 9. 98 divided by 14 is 7, no remainder, and then 0 divided by 14 is 0. Therefore, my answer for this question is 170. Again, no further working is necessary.